So here's a quality control kind of problem. The manufacturer makes springs, 5% should be defective. The customer can tolerate receiving 5% defective, but wants to do a quality control check to make sure they're not getting shipments with too many defective springs. So here's the quality control procedure. The customer decides to check 10 of the springs. That's going to be like our N. So the customer checks N springs, number of springs checked. The probability is whatever the true value of P is. So we're saying that supposing that the shipment was a good shipment of 5% or less, so 0.05, the question is, what's the probability that if they check 10 springs and they said they're going to reject it if one or more defective springs are found, what is the probability that one spring is defective plus the probability that 2 springs are defective plus the probability that 3 are defective all the way up to the probability that 10 are defective? So we could, if we had to do this by hand, figure out what the probability that there are 0 springs defective, just subtract that from 1, that would be the same thing as this. Program bin2 or tally will actually just do this just automatically. It'll find actually all these probabilities and add them up. So when you run bin2, which remember does the exact same thing as tally binomial, it first asks you for the true value of P, which we're saying is 5% in this problem. And then the number, the sample size, we're going to check 10 springs in this procedure. And we want to know the probability from 1 up to 10. So our lower bound is 1 and our upper bound is 10. All the program does is figure out those probabilities, adds them together, and spits out the value about 40%. So according to this, even though the shipment was good, if we follow this particular procedure, we're going to reject the good shipment about 40% of the time. So that's not good. That's you're rejecting too many good shipments. So here, suppose that we actually get, suppose the customer decides to check 10 of the springs and reject the entire shipment only if 2 or more. So here it was 1 or more, now it's 2 or more. That's the probability of 2 plus the probability of 3 up through the probability of 10. So we can do the exact same thing, just run program bin2 again with the p-value at 0.05 with the n value of 10, and we just want to know what are the probabilities from 2 up to 10 all added together. So that probability is lower, that's about 8%, so about 0.86%. 0.86, yeah, so about 8.6%, which is more reasonable. We will reject some shipments, but only about 8.6% of the time will we reject a shipment like that. However, if we follow that rule, then the question comes, what is the probability that we accept a bad shipment? So accepting a bad shipment means the probability of 0 show up or 1 show up, because we're going to reject at 2. If 2 or more show up, then we're going to reject. So we'll accept for 0 and 1. So if we run bin2 again with a p of 0.15 and the n of 10, so p of 0.15, so there are 15% defective springs and our sample size is 10. What's the probability that between 0 and 1 show up? So that's about a 54.4%. So about 54.4% of the time we're going to be accepting this shipment, even though it's a bad shipment of 15%. So there's this trade-off here. We're either rejecting too many good shipments or accepting too many bad shipments. And the main problem with this is that we're only checking 10 springs. If we up this to 100 or 1,000, it is less likely that we're going to have probabilities this big here.